Hi there, coders. Welcome back to my channel Web Coding with Ankur. Today, we are diving into the world of big O notation in JavaScript algorithm. If you want to write efficient code and ace your coding interviews, understanding big O is a must. So let's get started. Let's start with first topic. What is big O notation? Big O notation is a way to describe the efficiency of an algorithm. It tells us how the runtime or space requirement of an algorithm grow as the input size grows. Essentially, it helps us analyzing the performance and scalability of our code. As you can see that big O notation is equal to efficiency of an algorithm. Here, big O notation focus on the worst case scenario, which is crucial for understanding the limit of your code under maximum load. After that, as you know, that big O, also known as big O notation, represent an algorithm worst case complexity. It use algebraic terms to describe the complexity of an algorithm. It represents the worst case complexity of the algorithm represented by the big O notation. Now, move on to second topic. We have common big O notations. Let's look at some common big O notation you need to know. Firstly, we have O first for O1 for constant time, O log n for logarithmic time, O n for linear time, O n log n for linear arithmetic time, O n is to power 2 quadratic time, and 2 to the power n and exponential time, and O n not factorial time. These notation help us understand how the execution time of an algorithm increase with the input size. Now let us see some example of big O notation. In this, we have big number of examples here. As you can see, we have example one O1 constant time notation. Here, an example of O1 or constant time. No matter the size of the input, the function will always take the same amount of time to execute. Below, you will see a function with the get first element array, and here it will return the first element of an array with the index 0. No matter how large the array is, accessing the first element always takes the same amount of time. This is the constant time for O1 notation. Now below we have example number 2, O for n linear time. In this in this next look at O n or linear time. Here the execution time grow linearly with the size of the input. As the input size increase, the execution time also increases. Here, I will show the example of print all element array where it accessing the element and display its value. If the array has 10 element, the loop run 10 times. If it has 100 elements, the loop run 100 times. So it will the execution time grow linearly with the size of the input. Now we have a third example of O n is to power 2 quadratic time. Now let's see an example of O n to the power 2 or quadratic time. This is the common algorithm that it involves nested loop. As you can see, we have a function called print all pairs array. In this, we have two loops. One is the outer loop for let I is equal to 0 to I to length and I plus plus. And after that, inside that, we have a nested loop for let j is equal to 0. And after that, we control array of I and array of j. Okay. So if the array has 10 element, the inner loop run 10 times for each iteration of the 10 iteration of the outer loop, resulting in 100 iteration. So this is the common algorithm in big O notation. Now, as we have the move on to the next point, visualizing big O notation. Let's visualize these steps with the graph to better understand how they scale. As you have seen the graph of various big O notations here, seeing different types of big O notations from 0 and not to 0 2 to the power n or 0 n to the power 2, and you have three which have a better compatibility of 0 log n and 0 1 and 0 to the power n. Okay, as you can see, OP O1 remain flat no matter the input size. O n grows linearly, and O to the power and O n to the power 2 grow much faster, showing how quickly performance can degrade with larger inputs. As you can see that we have then there 0 O log n which is good, another like that. We have different type of notation below. We have showing the excellent to the horizontal case, O1 from excellent and best to the O n to the power 2 or O2 to the power n and O no n to the power not, horrible or the worst. These are the visualized big O notation which is shown here in this slide. Now we have reached to our last topic, conclusion. Understanding big O notation is crucial for writing efficient code and optimizing your algorithm. Whether you are preparing for interview or just looking to preview your coding skills, always keep big O in mind. If you found this video helpful, get it a thumbs up and subscribe to my YouTube channel for more coding tips and tutorials. Hit the bell icon so you can never miss an update. Thanks for watching and happy coding.